In the part 2, let me explain the terminology by adding the technical description to the details explained in part 1. First, let me explain displacement and velocity. Displacement is a quantity to express how long an object moves from a certain position. The graph on the upper left side shows the position per second of an object that is vibrating at 1 Hz. The mathematical expression on the upper right side is the general formula for a sine wave. The alphabetic character F stands for frequency, T for time, x0 for amplitude of displacement, the maximum moving quantity. A test producing a gradually changing vibration frequency is also referred to as a sine wave sweep test and a sweep test. The logarithmic sweep is a sweeping method in which the logarithm of the vibration frequency is proportional to the elapsed time. This graph also shows time on the horizontal axis and amplitude on the vertical axis. The upper graph is for logarithmic sweep and the lower graph is for linear sweep, mentioned earlier. In the case of the logarithmic sweep, it has the feature of sweeping slowly at low vibration frequency and fast at high vibration frequency, making the number of times of the vibration wave circles become uniform at each vibration frequency. Next, the degree of freedom, DOF. DOF signifies the statistical degree of freedom. Generally speaking, the larger the degree of freedom grows, the higher the reliability of an estimate value becomes. When the average number of times is raised, the linear curve turns out to be smoother like this graph. In the case of taking an average of 2 numeric values, it is called the 2 degrees of freedom. In the case of taking an average of 3 numeric values, it is called the 6 degrees of freedom.